How many black holes are there actually in the universe? Being literally known as areas of nothingness, black holes have a reputation of being one of those mysteries of the universe, which we cannot discover no matter how hard we try. There's just something about black holes which intrigues us, but unfortunately, we are limited due to the technology of our time, which is why we are unable to figure out what exactly is on the other side of a black hole. That doesn't prevent us from speculating other things, right? Before we proceed further, make sure to subscribe to the channel and press the bell icon to get regular updates on our videos. By speculation, we mean that we can still discuss about the number of black holes in the universe, right? Speaking of number, can you guess exactly how many black holes there are in the universe? Have you ever thought about this question? Before we can answer this question, we need to understand the structure and nature of a black hole. This is because a black hole isn't like your ordinary circle or ellipse, which you can find in the circumference of and send in your space shuttle to locate and search. What is a black hole? A black hole is a place present in space where gravity is so much that even light cannot escape once it enters a black hole. The gravity in and around a black hole is so strong that matter becomes squeezed into a tiny space. This is very likely to happen when a star is dying. Since no light manages to escape, then people aren't able to see black holes. They are invisible. Although some special kind of telescopes can help us locate black holes. These telescopes see how stars orient themselves and how they are in such close proximity with each other and what effect they have on black holes. How big are they? Speaking of their size, black holes can either be big or small. Scientists think that the smallest black holes are just as small as the tiniest atom. These atoms almost might be small in their size, but they have a huge mass. Another type of black hole is what is called a stellar. Its mass can be up to 20 times more than the mass of the Sun, and that is just outrageous. There can be a number of stellar mass black holes present in the galaxy of the Earth, which, if you don't know, is called as the Milky Way. The largest of the black holes are what we call as supermassive. These black holes have masses that are more than that of 1,000,000 suns. Scientists have proof on the fact that every large galaxy has a supermassive black hole present at the center of it. The supermassive black hole at the center of our galaxy is called a Sagittarius A. Its mass is equal to 4,000,000 suns, and it's able to fit inside a large ball which can very well hold 1,000,000 Earths or more. How are they detected? A black hole isn't seen because a strong part of gravity manages to pull all of the light into the center of the black hole. Now scientists can see how the strong gravity manages to affect the stars and gas around the black hole. Scientists can study stars in order to find out if they are moving in space or whether they are orbiting a black hole. Whenever a black hole and star are close with each other, a light of high energy is made. The light is unable to be seen by the human eye, and the scientists make use of the telescope in space. Similarly, along these lines of what NASA is doing. Formation of black holes. Black holes form when the universe was created or when it began. At least that is what scientists believe in. These black holes are made when the center of a giant star breaks down and falls within itself. When something like this happens, it causes a supernova. A supernova is when a collapsed star shoots a part of it into space. Supernovas are incredible to see with the naked eye, and they are some of the most aesthetically pleasing phenomenon this universe has had to offer us. Scientists believe that supermassive black holes were made in the same time as the galaxy in which they are present right now. You see how we picked up the word speculation at the start? That is because the scientists here themselves are telling us stuff about black holes while they haven't managed to come across a black hole themselves even remotely. Which brings us to our most important question on this subject today. How many black holes are actually out there in the universe? How many exactly? This matter has been addressed by a PhD student from SISSA, Italy. The student is Alex Sicilla, who is supervised by two of his professors from SISSA itself, as well as from other national and international students. Of course, a study of this magnitude can't be done by one person, and many people have to be involved if you are going to gather some success. In a series of papers published, the authors have worked on the demographics of the stellar mass black holes. Alex had to say on this, the innovative character of this work is in the coupling of a detailed model of stellar and binary evolution with advanced recipes for star formation and metal enrichment in individual galaxies. This is one of the first and one of the most robust ab initio computation of the stellar black hole mass function across cosmic history. As per a new research, around 1% overall ordinary matter of the universe is stacked up in stellar mass black holes. Researchers managed to find that a number of black holes within the observable universe at present time are about 40 billion. If you put it into context, then that is a humongous number. This is because it contains billions twice, which makes it a total of about 20 digits in a single value. This is how many black holes are present in the universe, and at this point, we are glad we can't see them because the universe must be completely saturated by them. As to how these black holes are calculated, we shall look into this in the next section. Stellar black holes and their origin. The number of black holes in the universe is not the only issue that was investigated by the people carrying out this research. According to their work, the biggest stellar black holes have originated from the dynamical events in stellar clusters. The researchers have gone on to show that such events are required in order to explain the mass function of coalescing black holes as predicted from the gravitational wave observations. Lumen Boko, co-author of the paper, comments, "Our work provides a robust theory for the generation of light seeds for supermassive black holes at high redshift and can constitute a starting point to investigate the origin of heavy seeds that we will pursue in a forthcoming paper. As mentioned before, this will be a series of papers where black holes will be focus of the study, and the heavy seeds that are mentioned here, they are most likely to be the biggest stellar black holes of which the authors have mentioned in their study." Calculation of black holes. An original approach has been chosen to calculate these black holes. It combines stellar and binary evolution code SEVN, which is developed by an SISSA researcher, Dr. Mario Spera, for empirical prescriptions which are relevant for physical properties of galaxies, the rate of star formation, amount of stellar mass, and the metallicity of the interstellar medium. All of these things are important elements that help define the number and masses of the stellar black holes. Using these elements with a consistent approach, thanks to this new computational method, will allow researchers to derive the number of stellar black holes and their entire mass distribution across the universe. On this, Alex commented, "The innovation character of this work is in the coupling of a detailed model of stellar and binary evolution with advanced recipes for star formation and metal enrichment in individual galaxies. This is one of the first and one of the most robust ab initio computation of the stellar black hole mass function across cosmic history. Black holes are a spine-chilling phenomenon. Many people might have sadistic wishes to be sucked by one, but it isn't even remotely pleasing as it sounds. A black hole can rid you of your existence, and there are more black holes in the universe than you have cells in your body. If that doesn't tell you enough about the number, then we don't know what will. Be glad scientists haven't found black holes yet."